Hey there, and welcome to this introduction to Scatterplots. Scatterplots are kind of fun. So far, all the data that we've been looking at in this school year so far has been linear data, that for every x, there's one and only one y. And when we plot those points in that function, it makes a perfect linear equation. It makes a nice straight line, either positive or negative. Well, now as we take a look at data and statistics, that isn't always going to happen. We're going to have bivariate data, so an x and a y, two different things that we're looking at. And when we plot those on the graph, they're not going to make a perfect line anymore. They're going to kind of go all over the place. And those are called a scatter plot. So on the screen, what you see right now are scatter plots. And so if we take a look at the two pieces of information, look at the trend of the data, kind of in general, which way is it going? We can see that from the scatter plots, there's a correlation, not a causation. Remember, causation is where one thing causes another thing to happen. It's raining outside, the ground gets wet. If you study for your test, you do better. There is a cause, whereas these are just correlations. Just do the two things that have anything in common. And what we want to look at is it positive, is it negative, or is there no relationship? Positive, negative, or no relationship. So what I can do is I can see by the data for number one that it's going in a generally positive direction. I could draw a line right up to the middle of the data as best as I can, trying to get half the dots on one side, half the dots on the other side. And that is called a line of best fit. A line of best fit. And again, I can draw that line up through the data, and I can definitely see that it has a positive correlation from there. Number two, if I draw a line of best fit through that data, I can see that it has a negative correlation. It's a negative correlation. But look at number three. That one, it has no correlation. There's no way to draw a line through that. That would make any sense. They're just scattered all over the place. Truly a scatter plot all over the place. Number four would be, you draw your line, see which way it goes. Try and draw your line right through the middle. So you try and get half the dots on one side, half on the other side. That would be a negative correlation. Number five, what do you think? No correlation. No correlation for that one. We say there's no undefined. It's either positive, negative, or no. These are your choices right here. Positive, negative, or no relationship at all. And then for number six would be, right, a negative correlation. Now the next thing you need to add into your notes, besides line of best fit, kind of an example what that is understand that this correlation either is going to have a positive one or a negative one or some number in between right there. So positive number one is a perfect linear equation. So if I'm graphing a line and I have a perfect linear equation, every single dot falls exactly on that line perfectly, just like the things we've been doing all along. That is a positive one correlation. That is a very strong correlation. So positive one is going to be a very strong positive correlation. Whereas negative, if I have like a perfect line that goes like this and it's negative and every single dot that I plot is on the line perfectly, they make a perfectly straight line, that is a negative one, negative correlation. So it would be negative. It would be a very strong negative correlation. And then everything in between. So 0 in the middle, 0 would mean there's no correlation. So number three would be an example of a 0. This one right here would be a 0 correlation. There'd be no correlation between those two things at all. And then there's numbers in between, right? There's a lot of numbers between 0 and 1 and 0 and negative 1. There's a lot of decimals that are in there. So if I have something like, let's say, decimal 23, negative decimal 23, then that is going to be a weak negative correlation. And if I have something like, let's say, decimal 36, that's going to be a weak positive correlation. So we go everything with this whole gamut from strong, positive, weak, positive, no correlation, weak, negative, strong, negative correlation. And it's kind of this whole like spectrum in between all on there. So the number kind of gives us an idea of how strong or how weak the correlation is. It's never greater than 1 and it's never less than negative 1. It's always between those two numbers in between there. All right. So let's take a look at the example on the bottom down below here. We're going to do the front side together and the back side you're going to do on your own. Let's move this up. All right. So here we have data, a table of data that's says many students take both the SAT and the ACT tests to apply to colleges. The table shows the scores that 8 Mathville High School students scored on both tests. So we're wondering, is there a correlation between the ACT and the SAT scores that these students took? So the first thing says is make a scatter plot of the data on the coordinate plane provided. So we're going to take the data and we're going to graph it. So 18 is going to graph to 800. Remember that a table is just a set of ordered pairs. So like this literally is an ordered pair. It's a coordinate pair and I can plot that point on the graph. 25 is going to go to 1100. So let's just take a minute and let's just plot this data. That's going to go about right there. And number 3, it's going to be 30, 1300. There we go. 21. Go ahead and plot your data, and I'll plot mine. Oh, I put a dot in the wrong spot. There we go. And I was at 27, that's 1200. There we go. I'm going to show you a way faster way to do this next class we're together. 16,600 and 22. All right, there you go. So pause the video if you're not making your graph, make your graph, and then press play again. So when I take a look at this, I can see that it is not a perfect linear line. That some of the dots are kind of like off in their little spots, different places. But what I can see is that I can draw a line of best fit. Let's see if I can grab a different color. So I can grab a line of best fit that I can draw kind of right through the middle right there. Okay. If I had a dot, by the way, that's kind of not at all like the others. If it's like very different, it's kind of off in left field or off in right field and kind of off in little spots. You know what that's called? That dot that's off on the side like that, that's called an outlier. An outlier. An outlier is a piece of data that just is like an anomaly. You could like just take that one and kind of like toss it aside. Like it's just kind of like this weird little thing that happens. So take care, don't do that one. Right. So I made my scatter plot and I drew my line of best fit. Number 9, does the scatter plot show positive or negative correlation? It shows a positive correlation. Is it strong or is it weak? It is strong. So I would expect that number to be close to 1. Not 1, because 1's perfect, but it would be close to 1. Draw the line of best fit. I already did that. Use the line of best fit to predict the ACT score of a student who scores 1,000 on the SAT. So then what I can do is I can use it to predict. So I can take my line of best fit. I can start at an SAT score of 1,000. I can follow that over to my line of best fit. I can follow it down, and I would be able to predict that student would probably score 24. So if they had 1,000 in the SAT, they're probably going to score 24 in the ACT. No guarantees, but based on the data trend, that's what I can guess. Predict the SAT score corresponding to an ACT score of 32. So if we go to 32 and we follow that up to the line of best fit and we follow it across, we can see that student is probably going to score around 1,400 on the SAT. We can see that there is a correlation between those two scores. Now, the one other skill I want to get to that is going to be on the back of the paper, because you're going to do the back paper on your own, is calculating that line of best fit. It's called a correlation coefficient. Correlation coefficient is how close or how far the, and my cat said bye and say hi. Say hi, Percy. We have a visitor today. Everybody say hi, Percy. You say hi, everybody? You'll learn about data statistics too. Correlation coefficient is how tight that data is to that line of best fit. Okay. We can also calculate the slope from the line of best fit, remembering that we can find 2 points. If I take that line of best fit, I can find 2 points, and I can find the rise over run is one thing that I can do. Or I can take 2 of these points right here. And if I have 2 of those points, I can find the slope, remember? And if I can find the slope, and I can take one of the points, I can write point slope form, and from point slope form, I can put it into slope intercept form. So all of that stuff that we did in our last unit carries over into this unit, where I can find an equation that goes along with that line of best fit. Okay, let me say that one more time. That line of best fit, we can calculate, we can write an equation for that line of best fit. We can take two of these points that are from the table right here. We could do what we did in the last unit, where we're going to take our two, we're going to find the slope, the double rainbow, find our slope. We could take the slope in one of the points. We could write point slope form like we did before, and then we can change it into slope intercept form. And we could write the equation of the line of best fit. There's a happy cat. Happy cats with his chin being scratched, right? Kitties love their chins being scratched. Okay, so you go ahead and you give the back of it a try, and we'll talk about it when we see you in class. So submit that paper for your homework by the time that it's due, and we'll go over it in class next time that I see you. Bye, guys.